Grade 5. Air resistance, what it is, and how can we test it? Well, air resistance is basically the friction between object and air. So when the air particles hit an object, they work in an opposite direction of the direction of the object in it. Mostly we're going to talk about a falling object, not a flying object. So when the object is falling in air, so this is the direction of falling, air friction, when the air particle hits the parachute in this case, they will resist the motion and try to push it upward. So it's basically like friction, but it's for air, therefore we call it air resistance. And why is it called air resistance? Because it does not make you go down further, rather it slows your fall down because it works in the opposite direction. Okay, so what causes air resistance? Basically air particles. When they hit the parachute, they stop it from falling down, so they oppose the motion of a parachute. Again, now why does an object go down? Well, because gravity works on their mass, so it pulls them down, while air resistance would try to resist that. Now, at any moment, if gravity is winning, which is most of the case, you will fall down. However, if air resistance wins, you will fall down under the effect of gravity, but much less. Now, if air resistance works or wins, you stay floating, but not for a long time. And yes, why do we use parachutes? Well, because parachutes simply increase the air resistance. You have more air particles hitting a parachute than the one hitting the boy here without a parachute. So you see, it has this surface being hit, so you don't have much air resistance. However, when you open a parachute, you'll have a much more surface, a bigger surface being hit by air resistance, so you have it at a bigger force. Doesn't mean you're not gonna fall, you will fall, but much, much slower, and you won't die. In the first case, chances is you're not gonna make it. Exactly. So what happens when you have a parachute? You get more air resistance. Well, the thing is the more surface hit by air, or more surface area hit by air, you will have more air resistance. So you slow down much, 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 much more than you would do without a parachute. Now, how would you test that? Well, simply you get a piece of paper, two pieces, same size of paper, same type, same thickness of paper, and none of them is wet. And what do? You make sure it's exactly the same conditions, because it has to be a fair test. You crumble one of the papers. Now, what's the difference between the crumbled paper and the flat paper? Well, look at the surface size. It's very small. The surface area here is very small. Now, look at the surface area here. It's extremely much, much, much bigger than the crumbled paper. So which one has more air particles hitting? Well, look, you have just this part being hit by the air particles, while in this case you have a huge surface being hit by air particles. So we say that the crumbled paper have less surface area, therefore less air resistance. The spread one, or the uncrumbled one, has large surface area and therefore will have more air resistance. So which one will fall faster and slower? Well, A would fall slower while B would fall, A would fall faster while B would fall slower. Now there's one question that needs to be answered. Which has more weight? Which has more mass in it? Both of them have the same mass, remember. Both of them started from the same paper, the same number of atoms. So here, weight is the same. But what's the difference? What's the difference between them? The surface. This one has less surface area, and this one has more surface area. Now, if you let them fall, which one will fall slower? The one with the bigger surface area. Yeah, this one. Which one will fall faster? The one with the smaller surface area. Why? This one has more air resistance and the other one has less air resistance. Now my question is, what if there was no air? Well, if there's no air resistance, both of them will be pulled at the same force of gravity. So both of them will land at the same time and speed because there's no air resistance. If there's no air resistance, all objects will fall under the pull of gravity, and the pull of gravity is the same everywhere. So they will fall at the same acceleration or speed. Okay? So, again, look at the diagram. It explains everything clearly. And please, if you don't understand anything about the example in the activity book, you have the model answers. If there's any question about them, please send it to me. And also you have the other pages of the book, the table, and the review flow box. Thank you. Have a good day.